Okay, in this video I show you how we use the circuit construction kit to be able to build some of the circuits as part of this lab activity. So when you click on this link here, it's going to open up something that looks like this. You're going to go to the lab portion of this simulation, so double click on that. This is your workspace. Off to the left you see a variety of electrical components that you can use to build your circuits. So you got a wire, battery, light bulb, resistor, a switch, and here you have some other components as well. For the most part, all you should really need are the first 3 or 4 items that are in this list up here. So onto the right hand side you see that we can show either electron flow or conventional current flow. Remember, it's the electrons that are the charge carriers for most of our circuits. They're easily removed from their parent atoms and can then flow around fairly easily through conductors. But if you want to see what conventional current would look like, you can certainly click on that. So I would leave it on electrons for our lab. You can add some values if you want to see what the values are for things like the battery or the resistors and so forth. You could do that. We have some voltmeters and ammeters. Part of this video is to show you how we might use these. I would keep your wire resistivity tiny. Wires themselves do have resistance, but we don't want that resistance to be affecting our circuits, so keep that down at the tiny level. As well, batteries have some internal resistance due to the chemical reactions that are occurring inside. Let's go ahead and keep that down at 0 as well. So let's go ahead and build one of our circuits. So I'm going to take, let's just take this one here. It's got enough components in it where I can show you how to use these, the simulation to be able to build this. So let's take this battery. We need one of those. Off of this battery we have a switch, so I'm just going to go ahead and take a wire, add a switch to that, and then start to add components like so. I know from this one that I have a single light bulb in this particular path, and so I'm just going to add that light bulb like so. Can lengthen that wire pretty easily in the simulation. Can't really do that in real life very well. And then there we go. We got our first branch sort of completed. I don't have that turned on just yet. We'll save that for a moment. Let's go ahead and take a look at our circuit that we need to build. It looks like we have another branch that has 2 light bulbs in it that's connected from this point to that point, and so let's go ahead and do that. Let's just add another wire to it. You can see that this is fairly easy to use, this simulation. Wiring these things in real life is quite a bit harder, and it's unfortunate that if we have to do this lab completely in a virtual environment, this is the only way for us to be able to do it. And so there we go. I have the circuit constructed as shown here. Now, I don't want to answer all of your questions for you here. I want you to go through and build these circuits yourselves, but I do want to show you how we might use some of these devices over here. Okay, so the voltmeter is a meter that we can use to measure the voltage drop or the potential difference across a particular device. I'm going to go ahead and turn this thing on for just a moment so you can see how this voltmeter works. If I want to measure the voltage drop across this light bulb, I simply take the black and the red electrodes and place them across the device. And what it's doing is measuring the potential difference or the voltage drop across that light bulb. If I wanted to do that across this point here, you see that I still get the 9 volts, and that's because these wires themselves offer very little resistance to charge flow, and so there's essentially no voltage drop across these wires because of that very low resistivity. If I wanted to measure the voltage drop across this device, I simply take those electrodes and place them across that device, like so. Okay, so the voltmeter is pretty easy to use. A very non-invasive kind of measurement. I don't need to modify that circuit at all in order for me to be able to measure voltage drop across the device. Now, there are 2 different kinds of ammeters that I want to show you to use. One of them is a very simple ammeter to use. It's very non-invasive, sort of like the voltmeter. I can just simply place this thing across that wire, and the charge would be flowing through that hoop. And through a process called induction, that's a topic for a later lesson, we can measure that current with an indirect measurement. I don't need to actually insert this thing into that wire. Okay, so we can measure the current anywhere that we like. Now, this is a non-invasive kind of measurement. If I want to use this kind of ammeter, I actually have to insert this one into that circuit. So what I'm going to do is I'm going to go ahead and insert it like so. And now I need to have that charge actually flow through that device, and then I can measure that current using this. Okay, so I can get that value in either way. One of these is a little bit harder to use. It's certainly, this is the one that we use oftentimes in the actual laboratory. It's a far cheaper component to use than this, but it is harder to connect up. Notice that the ammeter for this one needs to be inserted into the circuit, whereas the voltmeter can be connected across the circuit. Okay, so it's far easier to measure voltage than it is to measure current. So there we go, a little tutorial on how to use this simulation. Good luck with the lab.